Our aim's quite simple, it's to win races and then championships. And we do that working as one team, working on one large project throughout the course of the Formula One season. For every race we go to, we're redeveloping and redesigning the race cars that we take and put on track.
Our aim is to optimise the car for every race. The front wing is the first part of the car to interact with the air and has the most significant impact on aerodynamic downforce. Our ability to be able to modify the front wing, whether that's in pre-practice, practice, or even during the event when there is a pit stop, allows us then to optimise that element of the car and helps handling on the track and also affects tyre wear.
A front wing comprises over 80 individual elements. However, this is really just the tip of the iceberg. In actual fact, more than 800 parts will have to be processed in order to manufacture, assemble, and then test the new front wing. And before this can happen, we first need to design and manufacture a 60% scaled wind tunnel assembly, which will also include additive manufactured parts. When we're confident of the final design, we move to full-size manufacture, much of which is made from carbon composite elements. These are formed from precision-engineered moulds and patterns, all designed and manufactured using NX and NX CAM. These are then wrapped with layers of carbon fibre fabric and then cured in autoclaves to form extremely strong, durable but lightweight parts for the car.
The real challenge for engineering is the pace of change and just how quickly can they constantly develop this Formula One car in order to meet the demanding calendar that we race in. When you look at the complexity of a Formula One car now and compare that to 10, 20 years ago, they're highly complex, incredibly technical vehicles, and that requires a certain level of skill and tools and infrastructure within the business to develop that level of technology.
The front wing is a great example of how we need the PLM tools to allow us to collaborate efficiently in order to be able to get developments on the car quickly.
We work to a shipping deadline, the date that the components need to leave the factory in order to arrive at the racetrack in time for that race weekend. The pressure for the engineering team is to develop the car, come up with the best ideas, the best solutions for any given race, and push that flow through the business. Part of the reason that we've been such a successful team is really because we've been able to do more this year as a business than the previous year.
If we look at the range of complex parts a front wing alone has, you'll see how the breadth of Siemens PLM Solutions are used to create composite parts, metallic parts, electrical wiring looms, and even the jigs and fixtures that are used for testing performance and compliance. PLM tools allow the team to access the right information quickly, make smart decisions, and use our resources wisely.
We've been partners with Siemens since the very beginning of the racing team, and they're actually one of our longest standing innovation partners. We partner Siemens PLM for several reasons, but ultimately we partner best in class, which we believe Siemens PLM are. And then secondly, it's important for us that we have partners who can provide suites of software, complete solutions. I've been with the team since 2006, and I've been around the PLM platform since those early days. And to see what we do now with the PLM tools, it's worlds apart. We use a far greater suite of the product portfolio from Siemens. It touches a wider audience within the business, and it truly is the backbone to our PLM business. And yeah, it's mission critical to what we do as a race team.